Thanks for watching this webinar today. It's the June edition of the HbbTV Webinar series. We've got a great technical topic for you today, and despite this being a technical topic, we have got quite a lot of interest for this session. 133 people have registered to watch this live today. It's a 1-hour session as usual with presentations followed by a 15-minute Q&A. So of course, I'd like to remind you to submit your questions as usual through the chat box, and then our presenters will be happy to respond to them at the end of this session. The session is called Deploying New Developments in Dash Hardware-Based DRM, Multiple Periods and More. And we have a great lineup of presenters for you who are very familiar with this topic and are very much involved in it, and there are quite some news to present. This is for the first presentation, Daniel Silhavy, Scientist and Project Manager at Fraunhofer FOKUS. We have also from Fraunhofer FOKUS, Louay Bassbouss, Scientist and Senior Project Manager R&D. Then we go over to Finland at Sofia Digital. We have Juha Joki for you, who's Director Broadcast and Testing over at Sofia Digital. And we go to the UK for the final presentation at Digital UK in London. We have Mark Riley for you, who's Video Streaming Architect at Digital UK. Of course, you know, Digital UK probably most from its Freeview brand. So thank you very much for watching us today. It's the disclaimer first, as usual, to get everything straight for you. The presentations represent the views and the of the presenters and the companies they represent, not necessarily the views of the HbbTV Association. So let's get started and over to Berlin, where Daniel and Louay are waiting for us. It's Daniel who's starting with the first presentation. Thank you and welcome, Daniel.
Thank you, Jörn, for the nice introduction. Let me just quickly get my setup straight.
Exactly. We can see your screen, and there's the presentation in presentation mode. It couldn't be better.
Perfect. Just let me know if anything goes wrong here. Also, I have a bit of internet connection problems today, but I hope everything is fine. So okay. I'm very happy to be here today. My name is Daniel Silhavy. I'm here with my colleague Louay Bassbouss. We both work for Fraunhofer FOKUS in Berlin. And we will kick off this webinar with MSE-based media playback on HbbTV using dash.js. I will actually cover the first part of the presentation, so give you a quick introduction to dash.js and also have 2 slides on DRM and multi-period playback in dash.js. I actually had to cut down a bit, so I had 2 more slides, but timing-wise, they don't fit in this webinar. So we keep the introduction very short. Then I will hand over to my colleague Louay, who will give you an overview of dash.js on different HbbTV devices. And I think we also have a demo video in the end. Okay, let's get started right away. Dash.js development and latest features. So there might be some people in the call who have not heard about dash.js. Dash.js is the official reference player by the Dash Industry Forum, and our main goal is to play back Mpeg Dash content. As a side note, we also have support for a legacy format called Microsoft Smooth Streaming. So we do some kind of client-side conversion of smooth streaming to Dash directly in the player, but the main focus is really on playback of Mpeg Dash content. The player itself is maintained by Fraunhofer FOKUS, but overall the project is really community driven. So we have a lot of contributions coming from the outside, from different companies, and not only new features, but also bug fixes. And one of our main jobs is to review pull requests, check the code quality, and then merge that back into the player. The Dash.js project is open source, so it's available on GitHub. The latest version that we released was actually, I think, 4 weeks ago, version 4.4. I put the link on the slide. You can check it out now if you want. So everything is available on GitHub. There are many use cases for Dash.js actually. So the main use case is obviously we use it as a reference player for the Dash-IF IOP guidelines, but also for the Mpeg and ISO specification. So whenever there's something specified in these documents, then we try to implement that as fast as possible in Dash.js to have a reference implementation and provide valuable feedback to the organizations writing these specifications. Dash.js is also used in production, for instance, by the Deutsche Telekom and BBC. So it's production ready. You can check it out right now and use it as a foundation for your application or for your own player. And it's also used for academia and research purposes. So when people are writing paper, for instance, about Avr they can use dash.js, plug in their own code, plug in their own algorithms, compare the existing ones to the ones they implemented, and then more or less use these results in their papers. Dash.js is MSE and EME based. This means the code is completely written in JavaScript, and we rely on MSE and EME. This also means that if you want to use Dash.js, you can do it everywhere where MSE and EME are available. So this includes desktop browsers, smartphones, smart TVs, set-top boxes, and also HbbTV devices, as we will learn today. As I said in the beginning, I had dedicated slides on the different features that we support in Dash.js, but this would kind of exceed the limits of today's presentation. So I just want to give you a quick overview of what we support. There are many more features that are not listed here, but one of the major features that we do support in Dash.js is a very flexible Avr logic. So you can more or less plug in your own Avr algorithm. You can configure the player to use certain Avr algorithms. You can deactivate some stuff, activate some stuff, and do that in a flexible way and do your tests based on that and find the optimal configurations for your streams. We also spend a lot of time working on multi-period and DRM support. So this is something I have on the upcoming slides. I'm not going into details here. Some new technologies that we also support are Mpg patching. Maybe some of you have heard about that. The idea here is really to keep the Mpg updates during a live streaming session very small, so that you only provide the necessary information to the client instead of providing the whole Mpg again whenever there's something changed. We support also gap handling. So this is very important because the MSE it's not very flexible when it comes to gap in the media buffer. So whenever you have something missing in your source buffers, let's say audio or video, then you create a gap and playback will stall. So you need a player to overcome such situations. Also important for multi-period playback. So this is something we support in Dash.js as well, alongside support for something called CMCD, Common Media Client Data, a new CTA wave specification, and CMAF low latency streaming. So we also have a lot of different options available when it comes to low latency streaming and the settings you can use in the player. We also support various subtitle formats, and as I said, this is just a short list of all the features that Dash.js has. So we really try to implement all this in the specifications while keeping like an optimum when it comes to the performance of the player and making it usable also for production purposes. Going on already to the next section. So this webinar is focusing on especially multi-period playback and also DRM. So what I want to give you at this point is a quick overview of the changes that we did when it comes to multi-period, especially in release 4 of Dash.js, and then the different options you have when it comes to DRM in the browser, in the player. So multi-period playback. So probably most of you know what multi-period playback is for in Dash. So it's mainly used for techniques like server-side ad insertion, where you kind of structure your MPD in a way that you have a single period for your content, followed by some ad periods, and then the content period again, if you think about mid-roll playback. And also when you transition from encrypted to non-encrypted content and vice versa. So usually you have your content structured in different periods. For a long time, this was, let's say, very limited when it comes to playback of multi-period content in Dash.js. And with Dash.js version 4, we spent a lot of time optimizing this behavior. So one thing, and this is what you can see on the right side of the slide, one thing that we worked on for a long time is the pre-buffering. With Dash.js 3.2, I think was the last version, the pre-buffering of upcoming periods was really limited to a single period. And if you think of like short advertisement periods, short ad slates, then this can get really problematic on the client side, because finally this results in a very small buffer if you can only pre-buffer a single period that is about to be played next. So this limitation is removed in Dash.js 4. So the pre-buffering now contains multiple periods depending on the buffer target of the player. So this includes, for instance, in this example, 2 ad periods, an ad slate, and also the upcoming main content again. So this leads to great performance improvements. And as I said, we avoid situations in which the buffer is depleting because we only pre-buffer a single period. What we also worked on is the DVR window in dash.js. Again, some limitations in the 3 version of dash.js. If you think about the Mpg update, the Mpg attribute time shift buffer, then with version 3 of dash.js, this was limited to a single period again. So only the currently playing period was included in the DVR window in the time shift buffer. And with 4 version of dash.js, we removed this limitation. So whenever you have multiple periods in your time shift buffer, then this can also be used during playback. The user can seek to these periods and actually play back the content from these periods. Some additional changes. So we support the transition between encrypted and non-encrypted periods. This can also get messy depending on which kind of period you start with. I mentioned the gap handling we have in place before. So we overcome situations in which the implementation of the MSE stalls and the buffer is not continuous. There are various reasons for that: unaligned periods, sample durations not matching the segment durations, negative and positive EPT deltas, so kind of segments that overlap period boundaries. Same goes for the PD delta. We have added all this information in blog posts, but also in the paper that we handed into the Mile High video conference. So in case you're interested in the details, I can only recommend to check out these papers and these blog posts, in addition to the different examples we have available on the dash.js reference platform. Last slide from my side, talking about digital rights management. So as I said, we have a lot of options available when it comes to DRM playback in the browser using dash.js. Listing some of them here. We support PlayReady and Whitewine. I also added ClearKey here, although it's not a real DRM system, but maybe some of you are also familiar with the work dash.js is doing. We support the enhanced ClearKey protection, ECCP. That's also might be popular in the future. We support multiple EME versions. So there are different platforms that might not use the latest version of the EME. So in dash.js, we have different models available covering different versions of the specification of the EME. Basically 3 models: 01B, the initial implementation, the 2014 version that was used in the Internet Explorer, and the 2015 version, which we use as kind of foundation for everything that is adjusted in the EME specification. So the 2015 model is always the one that is up to date. You can provide your license server URLs via API and also via the MPD, so we are flexible here. You can also define a system priority. So in case you have multiple DRM systems available, let's say Whitewine and PlayReady on the same platform, then you can define a priority. So we select the one that is used with the highest priority and then try the other one in case this is not working. We also support key system string priority. This is essentially needed if you think about PlayReady. You have different key system strings available. You would use that dot recommendation string I have on the slide, for instance, if you want to do hardware DRM in the browser. We support DRM specific headers, so you can add your custom headers to the license request in order to fetch a valid license if this is required. We also support different robustness levels. So again, a very specific EME call, but in order to do level 1 Whitewine or any other hardware DRM, you would need to specify a certain robustness level as part of your initial call to the EME. We let you define callback functions to modify license requests and license response. And we also support preserving of media keys and media key sessions. So if you do some kind of channel switching and you do not reinitialize the player, then we can use existing media key sessions so that we don't do an additional license request again. Again, lots of samples available as part of our sample website, and also all these options I just listed, they are part of our wiki. You can find all the configuration and detailed descriptions also in our wiki. And with that, I would hand over to Louay.
Thank you, Daniel, for the introduction. And we will continue with dash.js performance on HbbTV in the next 3 slides. Yes, so basically, we all know that native dash playback is already supported on HbbTV. So the question is why we need MSE-based dash player like dash.js. So the answer is easy, basically for more flexibility. Imagine you can have faster bug fixing when you are using, for example, dash.js player, instead of waiting for a new software update on your TV set. But basically, because also you can introduce new features in your player. For example, one of the major use cases leading to introduce dash.js or MSE in HbbTV was low latency dash support, which already supported in dash.js players and maybe other players. It's not only limited to dash.js player, but dash.js is the most advanced dash-based playback on MSE-based devices. But there are also other HbbTV specifications that are requiring MSE. For example, HbbTV targeted advertising specification, which use MSE to give the application full control on the buffering behavior. So you can, for example, control the buffering in your application about the amount of data you want to download before the ad is playing, and so on. So you can see this on this slide. There are two use cases, but there are other use cases. You can also, in the past, we already used MSE to place 360-degree video on TV sets. So MSE was introduced in HbbTV version 2.0.3, but from our experience and lab testing, we all know that a lot of TV terminals with older HbbTV versions already support MSE on TV devices. And on the next slide, Daniel, if you can go, yeah. So you can see here, this is a test we did on TV devices we have in our TV lab. So basically, we tested MSE on dash.js player on TV terminals supporting different HbbTV versions. It's not only the latest HbbTV version, but also TVs with different HbbTV versions, 1.0.1, 4.1, and so on, from 6 different manufacturers. And you can see a lot of green here on this picture and this slide. MSE is supported, dash low latency is supported. Of course, this is not an intensive test. This is on our agenda to do more testing, but this gives you some idea if you want to use dash.js on existing HbbTV terminals, not necessarily the latest support introducing MSE and dash.js playback. You can already use it, of course, after testing and evaluation. Some of the devices already support MSE, but there are some issues, but these are related to MSE integration in the terminal and not necessary to dash.js. Next slide, Daniel. We have a short demo video, and in this demo video, you can see basically a dash.js playback, and the content you are seeing here is provided by the CTA Wave project within the device playback capability group. So we developed content there, and we use this content within dash.js to play on an HbbTV terminal. The terminal you are seeing here on this video is HbbTV 2.0.2. And the dash.js version is the latest one, is 4.4.1, and the content, as I mentioned before, is provided by CTA Wave project. So you have also everything available as open source online. I put it here on this slide, all the links to the GitHub project. So if you want to access this content, feel free. And yes, so we will continue our intensive tests and bring dash.js on HbbTV to the next level. Thank you for your attention. And as I mentioned, later, maybe in the Q&A sessions, if you have questions, feel free to ask us. Happy to support.
Thank you, Daniel and Louay. And now it's over to Finland, where Juha from Sofia Digital is waiting for us. Just let me use this opportunity. You've already been submitting your questions. So if you have more questions for remaining participants, please do submit your questions to a little toolbox that you can see. And now let's go over to Juha, who's got the presentation already running for you. Thank you.
All right. Yes, hello from my side. I'm Juha Joki from Sofia Digital, and I have been the project manager for HbbTV DASH-DRM reference application for some years now, and I'm now here to talk about that, and it's very closely connected to dash.js development as well. So it fits perfectly here. Let me move a little bit of the windows. So brief history about the application. So the development started for this in 2017. After it was recognized that the DASH-DRM playback was an interoperability issue in the existing HbbTV terminals, and there was some really suitable tests to verify the operation. So this application was then commissioned by the HbbTV IATF Task Force Improving Interoperability Task Force. And the goal of the project was to offer a toolbox of tested and proven components, enabling the implementation of a widely tested and working DASH-DRM reference player application for HbbTV. And the project also offers so-called industry best practice tools for content creation to test all these kind of different scenarios that are available here. The first commit was made in May 2017, and the first version was released for testing at the IoT Interoperability Workshop in July the same year. And everything is released under the MIT license, so it's completely open source and free to use. And now the project is celebrating its 5th birthday, and its development is still managed by the IATF weekly calls, or bi-weekly calls actually. And the application structure, all code is released under the MIT license, as I mentioned, in GitHub under the HbbTV Association account. You can have the URL there. And there are always 3 live versions available in the server that we are hosting for this refapp.hbbtv.org. There's a production version, which is updated at maximum 3 times per year, trying to be synced with the HbbTV test suite releases. Then there is the most interesting part, the staging, which includes features that are stable enough for widespread early access testing. So our goal here is to put things available in the staging after we have verified that our implementation is working on enough devices, and that's always our own interpretation, which is enough. And the testing instance then is a playground for new features that if we want to try out something that probably won't work, we will put it available in the testing, and if it happens to work better, then we are putting that to staging and eventually to production. And there are 3 profiles available. So there is OIPF profile, which uses the old AV object, and OIPF DRM object for video playback, so-called HbbTV 1.5 version. Then there is the so-called HTML5 version, which uses the HTML5 video player and OIPF DRM object still for video playback. So this is the HbbTV 2.0 version. And then there is an MSA EME version, which we just heard. This is using the dash.js player for playback. And this is also compatible with PC browsers and Xboxes and so on. So you have to remember that we started in 2017, so the world was a little bit different place back then, but now the MSA EME version and the dash.js development is more important now for this project as well, compared to what it was before. The DRM is of course available. We have PlayReady and Marlin and some clear key tests also, and we are using the ExpressPlay license server from Intertrust and the Microsoft test server, which are available for this application use. And then for content creation, we have a tool called Dasher. It can be used to create new test content and check how the existing content is made. We have a video library available in the refapp.hbbtv.org server, which can be utilized to create new content and check the existing content that is available. And here is a small diagram about the different versions and profiles. So each of these versions have the 3 existing profiles. So in all, you have 9 different versions available of this application at all times. There is a lot of collaboration with other projects, of course, open source projects. The MP4 box, FFmpeg, and FFmpeg are used heavily for test content creation. And we are closely following the dash.js player development, especially for the multi-period dash development, as we just heard. That is really the tool that we can validate our own efforts of creating multi-period content. And the staging reference app mode is using the latest released version of the dash.js player at all time. And we are also following the Microsoft Play Ready and Intertrust Express Play teams for license acquisition, security level, signaling development. A little bit more about the security levels also in this presentation, but I'm sure on the next presentation as well from Mark. What kind of tests are then available in the production? There is normal full HD playback, 4K playback, Play Ready with CNC signaling, security level at 2000, and single key identifier values. Multi-audio testing to switch between different audio tracks, in-band, out-of-band subtitles, in-band events, add insertion in the traditional way, a little bit clumsy way, but a working way, and then live dash using the live simulator tool, and also some touches of low latency testing using the multiple MOVDF and MDAT-boxes tests. And then in the staging, currently we have available the Play Ready security level 3000 testing using tests using the single key identifier and also multiple key identifiers to enable different levels of protection for video and audio. This is recommended by Microsoft, and this is using the Microsoft server, test server as well. So if you have read the Play Ready documentation, it is recommended that actually the audio should be in the clear and the video should be security level 3000. We have this version available, but also a version available where the video is protected with security level 3000 and audio is security level 2000. So you can have a go at that test as well. Then there is a static and live multi-period dash for testing the server-side and insertion, as was discussed in the previous presentation, and also interesting test that there was discussion with the gaps in the timeline and so on, what would happen with the player. So the subtitles are very common component that would have gaps in the timeline. So we have these kind of tests available as well for experimenting on the devices. And in the testing instance, we have some Google Widevine hardware and software level protection tests and security level 3000 with the Express Play license server. And since this project is all the time being developed, we also have let's say a roadmap available for this year. So CPCS Play Ready signaling key rotation and persistent licenses. Especially this last one seems to be pretty important for the content providers to let's say save on the license costs as well. And the persistent licenses have been proven to be a little bit difficult area, if one can say so. And one really important part of our project is test reports and analytics. So the project is producing a monthly test report, which is offering a quick overview of the actual current status of device implementations. And this is available for HbbTV members. It is an anonymized list with over 70 devices in active testing cycle from our testing zoo here in Tampere, Finland. And all the test cycles include the complete set of the test tasks, monitoring also the robustness of old features as well, the status of the new ones. And we hope that these results offer some insights to operators about the feasibility of how they can introduce and roll out new features to their networks. And also we compile monthly overall statistics about the usage, and there is some average features, how much the application is used on the monthly basis. And in 2021, we had over 60,000 users and or unique visitors, and some amount of data was also transferred. And here is a small snippet of how the testing testing sheet looks like in the weekly bi-weekly calls that we have. So it is a little bit like Fraunhofer is doing, but we have a slightly more devices, and also we are testing the native players, of course, which is not the dash.js job. The user interface is fairly simple, so you can just select different tests from the different categories. We also have an on-screen logger which can provide some information. Also, the logs can be saved to the server, and all profiles can be accessed from this single user interface, so you can change the mode from the settings screen from the user interface. And this is actually my final slide already. So the application, as I said, is under active maintenance all the time, and new features are always under consideration, and the development of the application is really guided by the HbbTV Association, HbbTV industry questionnaires, and direct feedback is received via GitHub and also via email. And we like to think that in our laboratory, virtually all the new devices that are coming to market as an HbbTV compatible device are using this tool to verify the correct functionality. And you can issue the bugs and feature requests to this GitHub repository, and we are welcoming all the feedback that we can get from the application. And some briefly about the next steps during 2022 and 2023. We admit that the code and the repositories need a little bit of cleanup, so we are doing that. Also, the documentation is always lagging behind a little bit. And we are continuing the testing effort, so all the time we receive a new device here in our testing lab, we will put it through the reference app and then give feedback to the manufacturers and also to the association as an anonymized report. And the development of new features is hopefully starting really soon after the summer break. That's it from my side. Thank you.
Thank you, Juha, for these insights from Sofia Digital. And Mark's already here, so let's move from Tampere in Finland to London in the UK, where Mark is waiting for us from Digital UK to take a look at the UK side of things. Thank you, Mark. We're looking forward to your presentation, and there it is.
Hello, yes, hopefully you can see it. My name's Mark Riley. I work for Digital UK as a video streaming architect, and yes, I'm going to go through our kind of experience to this point, up until this point, working with SL3000. So first of all, I'm going to really whistle through these quickly because I've got quite a lot of slides. So Digital UK, for those of you who don't know, owned by the BBC, ITV, and we support the Freeview platform, which is the platform, is the largest platform, digital TV platform in the UK, serving 18 million homes. So it's large. Oh, sorry, did it my presentation just go then? Right, hopefully it's all okay still. Yes, so we're built on the HbbTV standard, and we're potentially the largest user of HbbTV, perhaps in the world. So yes, the drive to use SL3000 is really coming from the studios. They want to protect their high value content, in particular UHD. So we are seeing the requirement come from the content providers being passed down from their agreements with the studios. We are looking at the sort of next generation and what the streams will look like. We still want to use DVB dash. We're moving far more to utilizing MSC and EME for reasons stated in the earlier presentations. So that saves me some effort. Also, the implication of this is we also need the Play Ready CDM support as well. And as I stated, our requirements seem to be reflecting the direction of travel for the industry. It feels like we're doing the right thing at the right time. Once you decide to use MSC, you've got to decide what player to use. So we considered perhaps developing our own player. but it's complicated and it's reinventing the wheel. Or perhaps each content provider could actually choose their favored player on the platform. However, this doesn't scale well and it's very hard to support and test. Or we could, perhaps you can see where this is going, or you could use an already available supported player, which is either open source or paid for. So this is where dash.js comes in, that you may have heard of. Currently, our current thinking is we're very much leaning to using dash.js. It's a conformant, it's actively support all sorts of stuff like dash see multiple periods, architecture. It's easy to work with and easy to contribute to. So that is something that we are, actively doing. The release process has a regular cadence and is well controlled. So our proof of concept work has been based using dash.js. So we have a concept just to get a state of as to how well SL3000 supports and also help the manufacturers actually move forward to support 3000 in their devices. We chose a Vestel device. Vestel is a very large player. They in the manufacturing game. They they OEM or various different brands. So if you go into a supermarket in the UK and buy Hitachi or Sharp or something like that, the chances are it's made by Vestel. This particular device uses the Vide browser, which is a very popular embedded browser. The device already supported SL2000 via the CDM and SL3000 via the native kind of OIPF player. The proof of concept uses the Microsoft Play Ready test server. The content is created and packaged by us, the UK, using a combination of open source tools like MP4Box, FFmpeg, of course, and our own proprietary post packager to emulate server-side add insertion, which is multiple dash periods, which is also of keen interest to us. So I'll jump into the findings. Which use there seem to be different the original one and all recommendation, because it has a postfix recommendation section on it. The thing is, we found it hard to actually sort of get a sense of what was the correct one to use. We noticed that different devices use different key systems. So, however, there seemed to be a clear picture that if we wanted the new features and we wanted to make sure that it was EME compliant, it's far more likely that it was going to be the recommendation key system, which supersedes the original one. Certainly it does with the Edge browser. So we decided to recommend to the manufacturers for the Freeview platform to use that key system to standardize. Having said that, dash.js is flexible enough, as mentioned earlier, to handle a hierarchy. However, we thought for the sake of scalability, we would encourage manufacturers to standardize. Number two, not all chipsets themselves support audio pipeline, so they can protect the video pipeline using SL3000, but not the audio pipeline. This is a limitation in the actual system on chip itself. However, this would appear to be moot, this restriction, insofar as our conversations with the content providers, it seemed clear that actually it's sufficient just to protect the video portion of the stream using SL3000, and audio can be protected either using SL2000 or lower. So that was number two. Number three, yes, selecting the security level. Property, so the implication is that would be used to set the security level. And then the question is, what values do we use? From trawling through the forums, there seemed to be a widely accepted, perhaps a de facto standard here, that 3000, 2000 and 150 for SL3000, SL2000, etc. would work. So, however, we never found this explicitly written down in black and white from Microsoft. So, but it does feel, at the very least, it's a de facto standard. Everyone seems to use it, and we thought it prudent to actually explicitly tell the manufacturers, this is the property you use, and these are the values you use for setting the play ready security level. Final finding, the C format, so the message CD, which is passed on to the license server via the player. It would appear that, in theory, the player should be totally agnostic to this, shouldn't need to touch it. However, based on the Edge browser's implementation, this message is wrapped in an XML document, and the player has to actually extract it. However, the Edge browser isn't representative of all of the other devices we tested, which tended to send it in a kind of raw format, which is either UTF or UTF-16. So we had to do some work there to make it play nice with dash.js, and there's an ongoing piece of work just to get that to work fully. Is a very minor change, which should hopefully make its way through the process relatively soon. So that is our 4 findings. In parallel, Vestel and Vue were busily working on SL3000 implementation and using our test stream and test app to sort of test against. And yes, 4 or 5 weeks ago, they actually provided a development release which actually successfully works. It works in a kind of complex scenario where you have a server-side ad insertion, where you have clear content mixed with encrypted content. So using multiple dash periods, also key rotation, etc. So I think it was quite a major milestone to have that device, and we expect other manufacturers to follow through relatively soon. As part of this, we need SL3000 unitary testing. We test simple tests, playback with video SL3000, audio SL2000. That's the representative use case. We're very interested in testing license persistence in the context of SL3000, license expiration, and the clear to encrypted and vice versa period transitions, which is a use case from server-side ad insertion. Yep, very interested in key rotation, either on a period boundary or a kid change within the actual media segment itself, or even using the root leaf mechanism. However, with regards to root leaf mechanism, it's very compelling on paper, but we found it any evidence that it's actually been tool in the world. So you know, be very interested to find out you know, if anyone's used it. Working to work with a CBCS encryption, play nice with HLS, and the content providers like it because it is not dash. So, and what's the patient? Sorry, just bear with me. Oh, there it is. Right. Okay, one final last slide, very quickly. Okay. One other thing we're interested in is actually content rights, etc., using SCSI 224. We're not sure if it's been done before, but we want to be able to signal restart rights and whether a user can skip ads. Also, we're interested in embedding TVA within the stream using Dash events. So we're doing all sorts of interesting things with Dash here, and that's the end.
Thank you, Mark, for the presentation. Apologies if there have been some technical problems at the end of the viewers, at least at my end, where a few dropouts. I don't know whether it was a problem with the software or with the internet connection we are using, but I think we did get most of your presentation. And certainly, as usual, you will be getting the presentation by email, the link to download it from the HbbTV Association website. So don't worry about that if you didn't get that all. And also the whole session, there'll be a recording on YouTube on the HbbTV website on YouTube, so you can download the whole session and watch it later again if you like, and also recommend it to colleagues and friends, of course. So let's get everyone back on, all the speakers back on the screen, because it's time for the 15-minute Q&A session, and we're right on time. And thank you so much for submitting your questions. There have been quite a few, as you can see on the screen already. Let's get started. They are in the order of the presenter. So I think the first one goes to Fraunhofer. How does pre-buffer work with low latency live stream on a multi-period MPD?
Yeah, that's a very good question, if I can start answering that. So actually, we did not see a low latency multi-period MPD yet. So we don't have any experience here, but obviously you're limited to your latency. So usually you cannot pre-buffer, I want to say, in the future, because segments and chunks are generated on the fly. But I can maybe recommend here, if you're doing low latency streaming and you want to do some kind of ad insertion, there are attributes in the MPD, available time offset, that you can, for instance, set to infinity. And if you have preconditioned content, for instance, advertisements, ad periods, and you can signal to the client, okay, this is something that is already there on the server side. You don't need to wait for it to fetch it. It's already there. So you kind of tell the client, okay, it's availability time, the availability time of the segments, it changes by setting this offset attribute. And then the client can pre-buffer ahead. And it's a bit confusing, but it looks like pre-buffering in the future. But essentially, you're really patching the segments that are there because it's an ad, it's preconditioned, and still playing at the live edge, not letting the user seek into the future, but getting some data ahead of time.
Okay, great answer. Daniel, let's stay with you. That next question directly is directed at you directly. So can MSE detect how much memory is remaining, because every model of STB or TV set has various amount of memory, and dash.js v4 is intended to buffer longer periods. Memory management looks more difficult. I'm curious how the performance is guaranteed in this circumstance.
Yeah, again, very good question. So from my experience and from what I know is that there's no method that lets you check how much memory the MSE and how much data you're allowed to put into a source buffer. And that's really a problem at some point. So worst case is you put too much data in your source buffer, you get a quota exceeded error of the source buffer, and then you adjust the buffer target. And this is what dash.js is doing right now. So once you run into this issue of having too much data in your source buffers, you kind of change your buffer targets in order to account for that. And this also obviously depends on the quality. So if you put I don't know, 100 megabits segment into the buffer, then you're very limited to what you can actually put in the buffer in terms of the duration.
Yeah.
Maybe I can jump in here on this question, because in HbbTV, this is a good advantage that HbbTV is not only requiring MSE in HbbTV 2.0.3, but also the specification defines minimal requirements on the terminal for the buffering. And if you go to section 9.6.13 media source extensions, so you will see there are minimal requirements on the terminals for audio to buffer 2 megabytes, video 24 megabytes. If it's if the terminal does not support Ultra HD, and 74 megabytes for Ultra HD, and 96 megabytes for Ultra HD with HFR. So you have concrete numbers, and this is good in the HbbTV specification because these are not part of the MSE specification.
Thank you. This is, I think, quite an interesting addition. The next two questions are to Juha. First one, why is the data anonymized in the test results?
Yes, good question. The simple answer is that we are distributing these results to the whole HbbTV association. So by nature, it needs to be anonymized. So no manufacturers are mentioned or widely available. So they are more of a statistics and not to pinpoint any certain manufacturer. But of course, we do have in our lab, we have the exact results, including the manufacturer and model. I can answer the next question also.
Okay, exactly.
So, and the question is can we get access if you have a project that you need to deploy or implement? Then we are happy to test that and then distribute the results as we agree, but not on a general availability. No.
Okay.
So, by request of the association and the project nature, all the result data is anonymized.
Okay. That I think explains it very well. So these are all the questions that we've had. So thank you very much for submitting these quite interesting questions. And of course, very much big thanks to you, the presenters, for these valuable insights into this very important forward-looking topic. And I'd like to use the opportunity to give you a few ideas for further events that you're, of course, very much invited to join. FOKUS Fraunhofer is going to have their traditional FOKUS Media Web Symposium in Berlin next week on June the 21st and 22nd. You'll see Daniel, Louay, and me and lots of other people involved in these items in Berlin. It's an in-person event, and you're of course still invited to join us in Berlin. There's the link, and you can still sign up for this event, 2 days in Berlin. There's actually a whole week taking place with lots of interesting things, so please do have a look at the Fraunhofer website and get more information on that. The HbbTV webinar series will continue, of course, but at first there is on June the 28th a session which is the very first preview session for the upcoming HbbTV Symposium Digital for the HbbTV Symposium, which is going to take place in November, on November the 9th and 10th in Prague in the Czech Republic. This is the digital experience preview event where the sponsors are going to present some of their latest new products and services, and also give you an idea of what they're going to present in Prague in November. 45 minutes, a very compact format, June the 28th, and you will of course receive an invitation for that. The HbbTV webinar series will also continue in July, probably third week of July. It needs yet to be fixed, but we have already a great topic for you. We're going to look at HbbTV developments in Italy. You'll also receive an invitation for that event. And of course, I've already mentioned the annual big event, the HbbTV Symposium and Awards, this year in Prague, November the 9th and 10th, in co-hosted with AKTV, that's the Czech Association of Commercial Broadcasters, and it's an anniversary edition because it's the 10th annual symposium. And as usual, of course, you are very much welcome to submit ideas for further webinars. Please send your ideas to webinar@hbbtv.org. And you can follow the activities of the HbbTV Association, of course, on Twitter and on LinkedIn. So thank you very much for watching this live webinar. And I'd like to remind you, of course, that there'll be a YouTube recording available on the HbbTV Association YouTube site. The presentations, all of them will be made available as PDF documents to download from the HbbTV website, and you'll be sent links to these documents automatically as you've registered to watch this webinar, whether you've actually watched it or not. But if you registered, you will get the links and you'll get all invitations to further sessions, of course. At the end of this session, there'll be a small survey for you. So please take this opportunity to rate the webinar so we can improve it. And thank you once again for watching us today. Big thanks to the presenters. Take care, and maybe we'll see you next week in Berlin. Bye-bye.
Thank you all. Thank you.
Bye-bye.
Bye-bye.
Bye.